Hi, I'm Mads Torgersen, the lead designer of C#. Since C# 7.0, we've created 2 point releases, C# 7.1 and 7.2, which add some small but useful features to the language. Let's start by looking at some of the 7.1 features. In C# 7.0, we added tuples, which can optionally have names for their elements. Here's a query that produces such named tuples. When we take the first element out of the query, it therefore is a tuple that has those element names, and we can access them by the names like we do inside of this interpolated string. However, the select clause seems redundant. In C# 7.1, we let you omit names when they're obvious and simply infer them from the expressions provided. So even though we didn't say that the tuples have element names, it's inferred for us. Next, let's assume that the post method is asynchronous. We need to await it. But in order to do so, we need to be inside of an async method ourselves. Well, luckily in C# 7.1, the main method can be async, as long as it returns a task or a task of int. This makes it a lot easier to get started with async. Finally, let's have a look at that post async method. It really should have an optional cancellation token parameter. Again, there's redundancy. The default expression repeats a type, a long one in this case, that should be clear from context. And in C# 7.1 it is. The language lets you omit the type in the default expression when it's given by the context. Let's turn now to C# 7.2. C# 7.2 adds a number of features around working efficiently with structs. Oftentimes, structs are used for performance reasons to avoid the overhead and unpredictability of garbage collection in high-performance scenarios. Even if you don't do this yourself much, chances are that a framework you depend on does internally at a lower level. Let's look at some of the new features that make it easier, safer, and more efficient to work with structs in C#. To start with, here's a large struct type for representing asteroids. Imagine there's a lot more in there. Now let's create a few well-known asteroids, a helper method to compute the distance between two three-dimensional points, and a method to compute the distance between two asteroids based on that helper method. Now we can find the distance between Brian May and Freddie Mercury. How cool is that? But since asteroids can be big, we don't like copying them when we pass them to the method. It's common instead for the method to take ref parameters and pass the structs by reference. Assuming points are also structs in this example, we can pass those by ref as well and get a little more of a performance boost. Now, starting with C# 7.2, we allow the receiver of extension methods to also be passed by ref. So now we can call the distance methods using instant syntax, dotting on the receiver, whereas previously you could only put extension methods on receivers that were value parameters. One problem with ref parameters, though, is that they allow the method to modify the original struct value. That's not always what you want. The caller may not want to entrust the method with this ability, and if the argument structs are read-only, then it won't even work. So for this reason, we've added a new parameter passing mode to C#, namely in parameters. In parameters, they're like ref parameters, except that they are read-only inside the method and they cannot be modified. So they're kind of the opposite of out parameters, really. Out parameters are required to be modified by the method, whereas in parameters are required not to be modified by the method. So in return for that inconvenience, if you will, or that limitation, we let you pass even read-only structs to them, as in this case. The in modifier on the calling side is actually optional. That's because the call cannot really harm the struct since it can't modify it, so there's no need to warn the caller about it like there is for ref or out parameters. Apart from avoiding an expensive copy, the call is nearly indistinguishable from a normal call by value, so we let you use that same syntax. And actually, for that reason, we don't even require the argument to be a variable. If you pass a computed struct value, such as a fresh asteroid here, then the compiler will automatically allocate a temporary variable for it and pass a reference to that. C# 7.0 added the ability to return a reference just as you can pass one in. Here we have another method that takes two asteroids by reference and returns the one closest to a given point, again by reference. Well, what if we want to take in parameters to this method instead? Then we cannot just return a ref, because then the caller may modify it, and we just promised we wouldn't. Instead, we like to return the ref read-only. That way, you protect the immutability of the in parameter even as you return it back to the caller. Now, finally, let's take a peek at a feature we plan to include in C# 8.0, the next major release of C#, which is a little further out. We've published a prototype of this feature, and we would love for you to try it and give us some feedback. The feature is one we call nullable reference types, and it's intended to help you avoid null reference exceptions and null argument exceptions. Who wouldn't want that? The core insight is that C# currently lacks the ability to express your intent when it comes to reference types. Are they supposed to be null here, or are they not? So, for starters, let's add the capability to express that intent. So here's a person class. It's supposed to have non-null first and last names. Everyone's supposed to have those, and we can kind of assume that, but not everyone has a middle name, so it's fine if that one is null. So let's make that intent explicit by adding a question mark to the type of middle name. The question mark doesn't really mean much in a language sense, other than it expresses your intent, kind of like a comment maybe. But if you have a question mark, you're intended to be nullable. And if you don't, you're not intended to be null. So the expressiveness of the intent is now there. But now, we also offer you a set of warnings that you can turn on, and that will help you behave according to the intent that you expressed. So now, all of a sudden, it starts helping you out. When we turn the warnings on, we find that there's a problem with this class. The default constructor does not initialize the first name and last name, so they will remain null, which is their default value, after the object is created. But they're not supposed to be null. We didn't put question marks on them. We can fix that problem. I guess we could put question marks on them, but we can fix that problem by initializing them to some non-null value, like the constructor here does. How exactly do we know that it's initializing the two fields to non-null values? Well, those don't have question marks on them either when they come in as parameters, so the whole thing just kind of tracks through. So now the class is all right. Let's look at a method that uses it. It does have a bug in that it may dereference a null middle name. So let's see how the feature helps find and fix the bug. First, it's going to warn us that it's assigning the nullable middle name of the person to a non-null local variable. We can fix that just by adding a question mark to the type of the local variable as well, making it nullable. So now the assignment is fine, nullable to nullable. But now we get a warning that we may be dereferencing a null value. The compiler won't let you dereference a nullable reference unless you convinced it somehow that it's not actually going to be null at the point of dereference. So how can you convince it of that? Well, the compiler does a flow analysis through the code, similar to how it tracks definite assignment today. So if you have appropriately ensured that the referenced value isn't null, then the compiler will see it. So one way to convince it is to check for null. In this case, if the local variable is null, I simply return out of the method. So the compiler is satisfied that if and when I reach the dereference, the local is no longer null, or we wouldn't be here. Another approach is to assign to the variable. Again, the compiler can see that no matter what path you took to get there, whether you went through the if or around it, at the point where you dereference it, the middle name is no longer going to be null. Yet another approach is to use the null conditional operator question dot. Of course, now we're returning a nullable int, not an int. So there's another bug there, but then we can go fix that. Either by changing the return type of the method and then fixing up the caller, or we can use the null propagating operator question and just return a 0 when the middle name happened to be null. So you see, the feature finds your problem and then leaves you free to fix it in whichever way you prefer. For more information about new and coming features in C#, check out the .NET blog and docs.microsoft.com. On the blog, you can also find instructions for installing the nullable reference types prototype that I was just describing. Thanks for watching, and happy hacking!